pack it and mock it. So Shivaling is having an overall experience of 13 years and here at Thoughtworks for almost 10 years. So he's having wide area of domain experience such as finance, insurance, and real estate. And he's passionate over taking QA trainings, and he is also passionate on taking automation related workshops. And over to you, Shivaling.
Right. Thank you. First of all, thanks to Anil and Lavnish for setting the context on the contract testing and moreover on the pact. That will set a basis for the presentation I'm going to continue now. Let me share my screen. All right, so I'll just give you a brief about how we leverage the benefit of the pact itself. As Lavnish also told us, like we should be aware of like when to use the pact, when not to use the pact. So we leverage the benefit of the pact. There is an additional version you get called pact mock server, where you could mock the behavior from the backend. So I'll talk about how we leverage the benefit of the pact and how we mock the application behavior which we used in our project. Cool. So before I get into the details, these are the things I will be talking around. First, let's discuss about our business case, the problem we had to solve. And then let's also understand about the mocking itself. And then let's try to differentiate what mocking is, what is the stuff. And then let's understand a little bit around the mocking tools which are available. And then let's discuss about the approach we have taken to solve the problem we are discussing about. And then at the end, we will also discuss pros and cons of the approach we have taken. Cool. With that, let's discuss the business case we are going to talk about. So this is, we were working for a client. Sorry for the confidential matter. I won't be taking the client name and the project name we are working on. This is basically a banking platform where a relationship manager will be assisting a customer to buy products. So customers are a high net worth customers where relationship manager and the customer would meet over a online platform, or the customer has walked into a branch and they have started an application. Let's quickly look at how would a journey look like. So here the journey is like whenever customer is willing to buy some of the insurance product or any other products. So these are high net worth customers. They want to manage all of their assets and liabilities through one UI or one platform. They don't want to go to a different providers and manage their assets and liabilities. So hence, there will be one relationship manager from a specific bank. This manager will be helping the customer, and they would say like, I'm interested in buying this product. The problem is like when the customer says they want to buy a product from XYZ, this bank should have a tie-up with that XYZ product, and journey should be seamless on the banking platform itself. And there will be to and fro transactions between the banking platform and the products platform. Right, so it's like an example when from your Amazon or Flipkart, you might be using UPI, or you might be using some other payment method or credit card payment method. You will be actually landed on that platform. You will make a payment and come back to Flipkart. Right? So something similar behavior the customer will experience. So when the first time customer and the relationship manager is meeting, they will be going through all the details, assets and liabilities details, and they will understand the product that customer wants to buy, and they will select a product. So once they have selected the product, they want to understand in detail. So there is an issue of the compliance as well. From the banking domain, you cannot share all the data to the product domain. And from the product domain, you cannot keep all the product related information on the banking domain. So there is a compliance issue as well. That's why a customer will have to be navigated to a products domain. So they will navigate to product domain. they will go through all the illustrations of the document and the product they have selected. There could be multiple products they would have selected. It will give an illustration of all the products. Once they have understood all the details of the product, so they will again be taken back to the banking platform. So there is to and fro movement happening between the banking domain and the product domain. So what happens, like once the customer understands the product and they make mind that they are okay to continue buying the product, they will have to also validate the assets they have, the liabilities they have, how much they will be able to make a payment for. They will go through all the details and they will generate a report. Once they validate everything, again they will be taken to the product platform to actually update more details around the payment, acknowledgement. They will have to do the signatures. It will be a long journey on the product platform. So they will do this journey, and then again they will be navigated back to the banking platform to do a finalization on the product purchase. So what they do is here they will have to upload all the document, they will have to take a snapshot, few documents they will have to keep it with the banking domain, and few documents they will have to share with the product where they have actually purchased. So this is the business case. Again, because of the security and the data privacy reason, I cannot show you the actual application. So we created a tiny demo application. I'll quickly show you the demo tiny application we created. Okay, so let's assume this is a banking domain where customer has gone through all the products. They have selected, they did a login, they have selected all these multiple products. They did understand the pricing, the benefits of the products, and there will be dependents for the customer. And now they are willing to go to the next domain. So here the handshake happens between the banking domain and they now land on the product domain. So here they will have to go through the illustrations of all the product. They will understand the product details. This is just the demo screens we have built to make you understand. This is where the customer will try to understand more about the product. Once they are good with understanding the product, they will go back to banking domain, and from here again the journey continues. So this is just a quick illustration about what would happen when the transactions are happening between the banking domain and the products domain where the products are actually residing. Cool. So with this problem statement we have, let's understand the challenges we have faced. Lavish and Anil were also talking about the third-party applications we would be integrating with, the dependencies we have. The product domain, there are two different teams who are developing the products itself. There is a product team, it's a company B, and we are a banking domain. We are developing all the customer and the relationship manager side of the application. And the product domain is developing all the product side of the application. So there is a dependency between each of us, right? So when they have to be ready from their side, we will also have to be ready, and we will be asking for the application to develop application to be tested on a daily basis. We want to run our automation suite in an integrated environment. We just don't want to test bits and pieces. And there is an issue of like, how would we report a failure? We wouldn't know where will be a failure. Is it on the banking domain or is it on the product domain? Who will take an ownership of the failure? How would you fix it? Right. And we also want to, at the end of the day, when we want to go live, we want to do a joint UAT, so that we will give a final sign off on the application. So on the same test environment, we wanted to test independently, and we wanted to test with an integrated with actual product domain error. So this was our problem. We wanted to run our automation suite, and we wanted to independently file the bugs and show the evidence, right? So where and root down the problem itself. These are the challenges we had faced, and the solution we had was we had to mock it, right? So unless we mock, we will not be able to test it independently and run our automation suite. So hence we decided mocking the entire application behavior. So with that, let's get into a little bit of understanding around what mocking itself is. Um, okay, can anybody talk about what is mocking? Okay, we can take a minute to understand from the participant side. If you have used the mocking tools, what do you mean by mocking? How you have used it? Good. Let me just continue. So we basically would like to imitate any behavior. We would call it as faking a behavior, where we would not have an actual application. We will be faking a behavior. In our case, we had to fake the behavior of the product application, right? So it's not just the backend behavior, even the UI behavior, assuming that you have gone through the application, you have made a purchase of the application, and then come back to the banking domain. You have to imitate all that behavior so that it will look like the end-to-end connected journey of buying a product, right? So, so you will sometimes you will also want to mock a different success behavior, right? So you may not be able to find all the data which you are looking for in your DB or a different way of creating the data, or you might want to imitate the failure behavior, right? So it's difficult to imitate the failure behavior. Like for a specific failure, you might be expecting on a specific data failure, on a specific failure error code, whatever it is. It's difficult to mock. It's difficult to create the data for those specific responses, right? So we use mocking in that case. And obviously, we want to manage the dependent system behaviors. Right? Like this example I am talking about, there will be for sure most of the applications we are working on, we are dependent on the different third-party systems, or within the project we are working on. In that project also, we will have a dependency on the sub services or the different APIs. So when those applications are not yet ready, or something has happened, the application has gone down, we will be dependent on the mocking. So, to continue with our application journey and remove that dependency, we will use the mocking. Cool. So most of us will have a confusion around what is mock and what is stub. Most of the times we use the word stub. Sometimes we use the word mock. Most of stub and mock are relative. Let's take a quick example around like what is the stub, what is the mock. So we basically substitute a temporary value when you want to stub anything. Let's say you want to stub a value. Right now, you might not have a value for an age. So you will pass a temporary value, and you have stubbed that value because one of the service which was supposed to give you actual age, which is not there. You have temporarily stubbed the value, and the response, you call it as a mocked response for the age. So that's the difference. So you can say like when you want to stub for a car, you can use a Swift car or any car, right? This is one example. Um, and but if you want to mock a behavior of a specific car, right? So then you might have to modify. Maybe your Swift, you want to behave like BMW, then you might have to bring in some features like maybe a dashboard or some of the engine features you are modifying to make it appear like BMW. You're marking your Swift as if it is behaving as BMW. And another example is your fake meet we call, right? So, or a mock meet. You find a right texture, a right thickness, and the taste as well, but it's not a real meat. You have substituted some of the elements to mock the behavior of the meat. Anyone else would like to give any other examples to differentiate stub versus mock? Anyone?
Okay, I can go if there's no one.
Ravi, would you like to
Yeah, sure.
give an
Yeah,
example?
I'll go it. So one thing that we wanted to do in our project was like, let's take the example where we are working. Here it's like we are testing the device and there is a client that's running and we'll have to send certain informations to the cloud. So this cloud piece is owned by a different team and their scope will never match with our scope. So which means like the release will be same, but if you're doing it in n sprint, they'll be doing it in n plus two. So our definition of done says that the story can be closed only when the automation of the story is completed if it's feasible. So we can't keep taking the story spilling over to the two sprints and it will actually affect our burn down chart and things like that, right? So in that case, this stub actually kind of played a major role. So there we completely black boxed our client, or which is the agent that's running on the device, and we were able to stub the entire cloud portal. So in that way, like whatever we wanted to achieve, we were able to do it. So one specific instance that we would like to call out is the config that we needed from the cloud side. It was not ready by the time when our code was there. So in that case, for manual testing, we can place the file manually and we can do whatever we want. But for an automation, to have an in-sprint automation, this particular stubbing concept will help us a lot, and it helped us a lot because we need not rely on anyone, right? Like one of the point which Shiva mentioned, it actually ignores or relieves us from the dependent systems. So we can test our agent in a complete black box. So this is how the stub has helped us a lot. So this is one example that I can think of. Yeah. Over to
Thanks a
you,
lot,
Shiva.
Ravi,
Anyone else
for
want to go?
anyone else? Cool. Thanks a lot, Ravi, on that. Let's proceed further. Oh, okay, Abhinandan.
Yeah, I would like
Yeah.
to give an actual example where we are using mock effectively. Assume we have doing the API testings, right? So definitely not all the APIs would be ready by the time you have your test cases and you want to start your test execution, right? So during the time, you need to verify for particular for the test you have written, right? You expect something like a status code or a response body, right? And that also can be used to see if whether on receipt of that particular status code or a response body, right? If your code is executed as expected. So mocking we can see effectively used as part of API testing as well.
Cool. Yep. Thanks, Abhinandan. Okay, let's move on. Let's understand some of the mocking tools that are available. Most of them, some of them you might be already using. So the tools I have listed here, most of them are our open source tool. Very few are paid tools. But so at least there is a free version for many of them, like mockable.io. You can quickly open a web and you can begin it. They will give you one subdomain for free. You can directly mock one of your subdomain and start working on that. That's the quickest way of mocking on the web itself without having to have your standalone server, anything. You don't need to set up anything. So rest all is listed here are open source. And so knock is one of the tool which is widely used in the framework, which is dependent on the JS framework. So they will use it for the UI integration tests, where you, again, as Abhinandan and Ravi mentioned, you wouldn't have your backend application ready yet, but you want to test your UI functional behavior and give a sign off. This tool comes handy. Like there is a simple node library. You just need to install that and add a mocks as per the configuration. That's a great handy tool. And there is another tool called Mockintosh. You can pretty much mock anything you want. Some of the other applications we were talking about, it is difficult to mock some of the async behaviors where you would have a Kafka, the queues you would have. It's difficult to mock there, but Mockintosh gives you the way to mock your async responses as well, and you can pretty much mimic your the performance testing parameters. You can control your latency and the bandwidth, other things you can control and run your mocked behavior of the application. And there is another tool called mock server, which gives you n different ways. You can have a Docker container, you can just have a Maven, you can use it as a Maven plugin. Lot many ways you can just integrate with your backend application mainly. I have seen mostly people using it on the backend applications. And Montaback is another handy tool, which is one of the first open source mocking tool. And there is wire mock as well. People do use it for integration testing and doing a standalone mock. These you will have to run the mock servers individually. Let's quickly see an example of how a Montebank would work. All you need to do is just do an npm install of Montebank. One moment. Yeah, so you just do npm install of the Montebank and run the command mb, and you have your Montebank server running. And whatever the endpoint you want to mock, you just, let's say here, I am trying to mock this behavior. I don't see any response here. There is an easy way of, they call mocks as imposters. So what you need to do is, like, on what port you want to mock a behavior. So on this port, I want to mock a behavior for user endpoint. So I just create this, and this is up and running for me to use a mock behavior for user endpoint. This is as simple as that. Like you see, there is a response, success response created. Yeah, so Monteback comes handy when you want to mock a behavior standalone. So you just need to create an imposter. They're basically your mocks and start using it as an API. So later, I will also share this link. You can try using Montebank in your application as well. Cool. Now let's come back to the approach we have used to solve the problem we have discussed before. Because ours was a complex problem where we had to navigate between the application multiple times. What happens here again, let's look at a mock behavior, what we have done, and then I will take you back to explain you the tech implementation of how we used it. Cool. So instead of using the actual endpoint, all we had to do is, like, let's say I'm using a mock behavior. What it will do is, like, instead of taking me through the entire journey of the product domain, I will just capture only the necessary details which I need to pass from this domain to the banking domain. So it will look for some of the details where it will look, yeah, it will have a product ID. It will get the RM details and the password details. All you need to do is just pass the details which is required from this domain to the banking domain. So you just pass that details, and our application will capture the details and navigate you back to the banking domain again. And for the second time of the journey, we do the similar journey. How we have achieved it, I'll quickly run you through. Cool. So we understood about the mocks which are created using the pact, right? So in the previous session, we have our application created with contract testing. Only thing we had to do is leverage the benefit of the pact mock server, where you could add additional mocks to test your functional behavior of the UI application. What we have done is like from the PackMock server, there are already existing mocks. To mock the specific behavior of your journey, you need to just go and add additional mock interaction like this. So you would go to an interaction section of your specific service and endpoint. So let's say this is an endpoint for the product. What you would be doing is like to mimic the behavior of the different payload type, you would just add additional interaction like this and change your payload type based on the contract that has been defined. So I have added additional response here, additional interaction here. So based on this specific payload type, and there will be a specific behavior that would be triggering and a different data which will get loaded. This is how we added an interaction for a different behavior we had to mock. So once we have added the interaction, we had to create a mock UI application. So what happens is like from our UI journey, let me take you back to the UI journey here. Okay, when I click on proceed here, this proceed button, this actually creates a payload, which I have just shown you here. It's creates this payload and makes a post call to a dependent system. And once our dependent system receives that payload, it will send a redirection URL saying, okay, I have acknowledged your payload. Now you will redirect on this endpoint. So only then it will take you on this specific screen once it has acknowledged and it has passed the redirection URL. So what we had to do is like instead of landing on this screen, so in our response, we said instead of going to the actual redirection URL of the product site, redirect to this test site we are building. So what would happen is like we would have mocked the endpoint. Instead of hitting the actual product endpoint, it will hit the mock endpoint. And our mock endpoint for a specific behavior, it will give a redirection URL saying like redirect to this URL, and it will redirect to the specific URL we were talking about. And when you redirect to this URL, here, this is our mock UI application. So we had to create this mock UI application. So for different behaviors, we had to mock. So we created one JS instance, JavaScript node server we created, and all the mock behaviors were kept in that. And so once you have that, so you also you capture the details that is required and compile that information and send it back to the actual application. Now our main challenge was we also had to control a behavior to mock or no mock. We have a same environment that we could use between us. That means like we and product domain. Both of the systems had to use the same environment for the actual UAT testing. So when were pointing to the mock system, they were saying like application is not working properly. When we were pointing to the actual endpoint, most of the times it was broken. To solve that problem, what we did is like we used FF4J feature control mechanism, where we introduced an option to control the mocking behavior. How we could do is, yeah. So in the backend framework itself, we introduced the control called enabling the mock domain. If it is turned on, you would actually do a mock journey. If it is turned off, it's a no mock journey. And similarly, and we had a next problem. What the problem was when the system was being used, we were also developing in parallel, right? So we had to test the other behaviors of the application. There was a need that few people wanted to use the actual endpoint to test the current behavior which is supposed to go live, and the current development behavior few people wanted to test with the mock application, right? So to control that behavior, what we did is we also introduced that toggle with the RM IDs. What we did is like in the FF4G, we also introduced a configuration where we said only these many users will be able to use the mock, rest all use the actual application. This is how we did control the mocking behavior. When the control is turned on, it will do the actual mock, but it will also look for the specific user IDs. And next, how we did control the mocking behavior on the production. We could not go live to production with this mocking behavior. So there is a beautiful concept in Spring where you could do a profiling enablement only for a specific environment, where you pass the environment for this specific speech feature toggle and say like this profile, this is applicable only for a specific environment. So that means like whatever the toggle you have turned on off in production, it doesn't take any value. That's how we could control this mocking mechanism in the test environment and for specific users. Cool. Any questions? Okay, let's move on. All right, so let's quickly discuss about what are the pros and cons about this approach we have used. So Muthu has a question. Muthu, go on.
Yeah, Shivaling. So is it mocking has any limitation? Like, say for example, if you want to create a number of data, then how would it be? And if this has any limitation for creating mocking?
Yeah, so let's quickly discuss about pros and cons. Let's see if it answers your question. Otherwise, let's specifically discuss about that.
Yeah, sure.
Sure. Yeah. Cool. So here, this gives you an opportunity to test your application behavior anytime you want, not just the backend behavior, even the UI behavior, which will help you connect end-to-end UI behavior. Lower maintenance, because we are already capturing the contracts for, even though this is not a consumer-driven contract test, but still we are capturing the contract for the consumer side of testing purpose. So hence, whenever there is a change in the contract from the provider side, we still have to update our contract on our side, which is both benefit or the maintenance overhead as well. But we took it on the other side, on the benefit side, to keep the contract well updated all the time. And you could test any type of behavior. You are not limited to test anything specifically. And then you could test it any of the dependency independently, right? So you need not wait for any of the dependent application to be available and up and running. Some of the cons we see. We had to add an additional code in the service side of it to control the mock versus the real behavior. So there won't be a performance hit, but still there is a slight check, right? So every time it will check for that profiling. Oh, okay, if this is test profile, then execute this. So there is this additional code we had to keep it in the production code, right? So which is usually not recommended, which is not being used in production. There's a saying like, if something is not being used in production, get rid of it. But here we had to use this a slight additional code only for controlling this mocking behavior, right? So now it will come to a point that it will be a maintenance overhead, right? So we will have to add additional MFE, and you have to maintain the mock server because this is not a consumer driven contract testing, right? So we are testing a third party system. So for that, we are still maintaining the contract and we are still maintaining the mocks, and it becomes expensive when it comes to add a different additional behavior, right? So today we'll be testing for product A, the contract might be different. I want to test for product B. As long if the list keeps on growing, it becomes a maintenance overhead. So it is doable. You can add as many interactions, as many mock behavior as possible, but it's maintenance overhead, right? So let's say tomorrow there is a slight change in a contract, you will have to go and update all your mock data you have added there. So that's a drawback. And with this approach, you cannot test the actual performance of an application. You will always have to be dependent on the actual application to test the end-to-end performance, what we call it as. Muthu, hope it answers your question as well.
Yeah, but not really. Actually, my question was like, say for example, we have a upstream, so we are getting all the data from the upstream. So for each and every hour, we need to get data like around 10K or 20K. So like that, is there any limitation? So as you mentioned, you can we can test any type of response behavior, but when it is comes to getting data from a DB like big data, so I'm asking.
Yeah, so I get your question. So it is not recommended to use this approach when you have to test it against the huge data. There are different approaches that you could follow when you are trying to mock different behaviors. When the huge data you will have to place. So what we have done is like for one of our application previously, we had created a mock data containers. So based on the application behavior, we had multiple mock containers. So let's say you want to test the behavior of an application when patient details are, I'm just giving an example, when the patient load is 10K. So what we would do is like we will hook a container which has the 10K data of the patients. So when you have to test it for 20K, just remove this container, hook the 20K data container. So based on the need, we had created multiple containers and just hook it whenever you want to test that specific data size. For different problems, we might have to go with the approach that suits the need there.
Yeah, got it, Shivaling. Thank you so much. Yeah.
Cool. Any other questions? All right. With that, so we pretty much covered what we had discussed before. We went through the business case. We did understand what mocking is. We did try to understand the difference between the mock and the stub. We did go through some of the mocking tools, the approach we had taken to solve our problem, and we did understand the pros and cons of this approach. With that, I close my presentation. Any questions we can discuss? Cool. I take it as no. Thank you all.
Yeah, thank you, Shiva. This was a really awesome session, and yeah, really, as you said, right, mocking will be playing a vital role in the software development, and everyone will be using in future and in software development. All right. So we will be shared the feedback form in the chat. So we are looking at feedback. So how the session was gone, and what needs to be improved from our side, and what's nearly the inputs which really makes us to giving a valuable
tech stacks or knowledge sharing, so everything. So please provide your feedbacks in the Google form, right? Yeah, and you can also share one more time. Yeah. So with that note, thank you everyone. Thanks for joining the session. And if anything you want to share or you want to interact with speakers, or if you want to provide any live feedback, yeah, please unmute yourself, and we would be really appreciate if we shared any feedbacks. Yeah, please stay. We'll be taking 2 minutes of that. If you unmute yourself and provide any, if you have it in mind, or share your feedbacks, that's really helpful for us. All right. Okay. Thank you. So happy weekend to everyone. And thanks once again who joined and who gained the knowledge. Hope you got a good knowledge. And yeah, thank you everyone. We'll see you back in soon. Please stay. Yeah, stay tuned our web page, or follow up our LinkedIn page, social media, and Thoughtworks pages. Yeah. Thank you everyone. Thank you all, and thanks for organizer, and thank you speakers, and thanks all participants. Thank you everyone. Bye bye.
Thank you so much. Thank you all.
You.